the crew and ground teams to practice operations essential to the success of future missions. On launch day, the Artemis II crew suits up, undergoes final checks, and rides in the crew transportation vehicles to launch Pad 39B at NASA's Kennedy Space Center in Florida. Stacked on the mobile launcher, NASA's 322-foot-tall SLS, or Space Launch System rocket with the Orion spacecraft, awaits the crew, having made its 4-mile journey from the vehicle assembly building on the crawler transporter to the pad. The launch team fills the SLS propellant tanks with over 700,000 gallons of liquid oxygen and liquid hydrogen, and verifies guidance, communications, and avionics. At 12 seconds before liftoff, the hydrogen burn-off igniters fire. About 6 seconds later, the rocket's 4 RS-25 engines ignite. When the countdown reaches 0, the umbilicals retract, giving SLS and the crew in Orion the clearance to begin the journey. The 6 million-pound moon rocket produces 8.8 million pounds of thrust to accelerate towards space. 75% of this power comes from the two 17-story solid rocket boosters, each producing 3.6 million pounds of thrust. About 2 minutes in, the boosters are released, their solid propellant consumed. The core stage and its RS-25 engines continue to propel Orion and the crew to space. After 3 minutes, the protective fairings surrounding Orion's service module are ejected, exposing its solar arrays. 6 seconds later, the launch abort system is ejected from Orion. The crew has safely reached Earth orbit, though they could still abort using service module engines. About 8 minutes after launch, the SLS core stage engines shut down and the interim cryogenic propulsion stage, or ICPS, and Orion separate from the core stage. Orion and the ICPS are now flying free. Orion's 4 solar arrays deploy, powering the spacecraft and charging its batteries for when it moves out of direct sunlight during the journey to the moon and back. After a 90-minute orbit, the engine of the rocket's upper stage, or ICPS, ignites to raise Orion to a high Earth orbit. To pilot the spacecraft as they approach and back away, assessing Orion's handling qualities, hardware, and software. Following the demonstration, spacecraft data is collected to verify system performance, such as life support, communications, and navigation, ensuring Orion and the crew are ready for the voyage ahead. About 23 hours later, Orion's service module performs the Translunar Injection Burn, or TLI, pushing Orion out of Earth orbit and on an approximately 4-day trip to the moon. Ultimately, the crew's figure-8 flight path extends more than 230,000 miles from Earth. During the trip, the astronauts continue to evaluate the spacecraft systems and practice emergency procedures like testing the radiation shelter. The Artemis II crew travels about 4,600 miles beyond the moon, becoming the first humans to lay eyes on the lunar far side in over 50 years. Their observations will help us prepare for future missions at the moon. During this period, there will be an anticipated communication blackout between Mission Control and the spacecraft. As the crew returns from the far side of the moon, Orion is drawn home by Earth's gravity in a free return trajectory, ensuring a fuel-efficient 4-day trip. Before entering the atmosphere, Orion's crew module separates from the service module. 12 thrusters ensure Orion is properly oriented at an altitude of about 75 miles from Earth's surface. Orion and the crew enter Earth's atmosphere at a speed of nearly 25,000 miles per hour. Decelerating at a rate up to 4 times the force of gravity, the crew will feel 4 times heavier than they do on Earth. Orion's heat shield protects the spacecraft from temperatures of about 5,000 degrees Fahrenheit, about half as hot as the surface of the sun. To slow its descent, Orion begins a precise deployment sequence of 11 parachutes. 3 forward bay cover parachutes first separate the protective thermal cover that sits over the chutes. 2 drogues slow and stabilize the crew module, then cut free. 3 pilot chutes lift the 3 main parachutes, deployed at an altitude of 9,000 feet and traveling 130 miles per hour. These chutes slow the crew module to a speed of less than 20 miles per hour. After traveling more than 595,000 nautical miles, Orion splashes down in the Pacific Ocean, about 50 nautical miles from the California coast, just 16 minutes after entering Earth's atmosphere. After splashdown, a recovery team that includes the U.S. Navy, Air Force, and NASA approaches Orion. The team ensures it's safe for the crew to exit before divers help the astronauts onto an inflatable front porch, hoist them into helicopters, and fly to the recovery ship. Orion is towed into the ship for its return to Kennedy Space Center. Their mission complete, the crew is flown back to land and step on solid ground for the first time in 10 days. This is Artemis II. Learn more about Artemis at nasa.gov/Artemis.
NASA is preparing for a journey back to the moon, and after that, we're setting our sights on Mars. To get there, we need tons of rocket power coming from our Space Launch System.
When it comes to how much power this thing can push out, this thing is massive.
It's going to be mesmerizing to stand next to this massive vehicle. The immensity of it, knowing that this thing is going to be propelling a rocket into space and around the moon.
Hang on, it's probably best to start back at the beginning. It all started in Promontory, Utah, where Northrop Grumman manufactured each of the segments that make up the rocket's boosters. After a 10-day cross-country journey, the booster segments were delivered to Kennedy Space Center's Rotation, Processing, and Surge Facility, or RPSF. If this all sounds familiar, that's because it's the same facility that was used to process shuttle booster segments, which all came from Utah. Then they're ready to go to the iconic Vehicle Assembly Building, or VAB, where the rest of the motor segments are assembled and stacked on top of the mobile launcher.
So the one thing about this vehicle, of course, it's produced all across the country. Components all come here. They may be built around the country, but they all come together right here in the Vehicle Assembly Building.
Our SLS rocket will generate 8.8 million pounds of thrust to break through Earth's gravitational pull. That's more power than the Space Shuttle and the Saturn V rocket used. Teams with NASA's Exploration Ground Systems are responsible for assembling the boosters that will house the majority of that power. The twin solid rocket boosters, made up of 10 total motor segments, will stand nearly 17 stories when fully stacked. First, teams will inspect and prep the hardware. Next, they're ready to start stacking the segments, a process that takes time, patience, and a steady hand.
Once we have everything done in High Bay 4, we pick up the segment with the 325 crane, pick it up over the 16th floor crossover to where you see it now, and we begin stacking the segments. Each segment, we lift over the 16th floor crossover and stack it. Once we stack it, we put it on top of the segment below, and we put about 177 pins all the way around the whole thing to attach each segment.
And the pressure to perform the operation flawlessly can test the team's nerves.
There's a tremendous responsibility involved with processing flight hardware like this. It's nerve-wracking at times, but it's exciting. There's zero appetite for risk in a program like this.
We have a bunch of shuttle guys that are here to show us along the way. You know, if we get stuck, they're there to guide us. At the beginning of the stacking, it was very nerve-wracking. You know, with each segment that we stacked, a little bit of the nerve comes off. By the third or fourth one, it's easy peasy. You know, we're pushing through, all the jitters are gone, and we're just excited to get finished with it.
With all 10 booster segments now fully stacked on the mobile launcher, there's just one final piece of the puzzle to round out the power needed to get SLS off the ground and send it to space. Core stage. After a 900-mile journey aboard NASA's Pegasus barge, the SLS core stage, the largest rocket stage NASA has ever built, has made it to Kennedy Space Center.
Today is a huge day. This is the last piece of big hardware that we need for Artemis 1 processing. And we've just been waiting a long time for this part of the vehicle to arrive so that we can get going on the next steps of our stacking operations.
Standing an impressive 212 feet tall and weighing a whopping 188,000 pounds, the core stage came all the way from